Good morning, everyone. Welcome to our webinar on hydrogen brought to you by the Global Epicenter of Mobility here at the Detroit Regional Partnership. I am thrilled to be here this morning with a couple of experts in the field. If I can introduce them to you, we have Jim Saber, who is the president and CEO of Next Energy, a Detroit nonprofit that works with innovators to accelerate smarter, cleaner, more accessible solutions for communities and cities. He currently serves on the boards of the Detroit 2030 District and the Michigan Institute for Energy Innovation as an external advisor for DTE's Emerging Technology Program. He contributes to the Department of Energy's industry peer and annual merit review efforts within vehicle technologies and hydrogen programs. He also serves on multiple Society of Automotive Engineers standards committees for hydrogen and fuel cells. He holds a degree in electrical engineering from Lawrence Tech. We also have with us Tarek Abdel-Bassett, who is currently the Director of Business Development for Hydrogen Storage Systems in North America within the Clean Mobility Division at Forvia, where he's leading the company's zero emissions business development activities in the region. Prior to his current role, he served as Chief Engineer for Forcia Hydrogen Storage Solutions. And before joining Forcia, he was the advanced electrified propulsion systems engineer at Stellantis and held various positions at Fiat Chrysler, including program manager, fuel cell and hydrogen storage engineer, and business and policy strategist. He also served as Chrysler's representative to the U.S. Department of Energy on Freedom Car Consortiums, aided as the industry co-chair for the hydrogen storage tech team, and led industry participation on the development of DOE's hydrogen storage targets for light-duty vehicles. He holds a degree in chemical engineering from the University of Waterloo. And I'm Christine Rader. I am the Executive Vice President of the Global Epicenter of Mobility initiative here at the Detroit Regional Partnership. I'm going to walk you through the agenda this morning. We're looking to give you a little bit of background on what our future mobility technology study is. And then we'll go into some short presentations from Jim and Tarek, and then we'll have time for Q&A. So looking forward to the next hour with all of you. And please be sure to put any questions you may have into the chat, and we will be sure to get them answered. So for any of you that aren't aware, the Global Epicenter of Mobility is a program that was created via a $52.2 million grant that was awarded in 2022 to the Detroit region. You see the map here that shows what we define as the Detroit region. When you look at mobility as an industry, it really is the heart and soul of this region. You can see on the map, we have well over 1,000 assets in our region. And as this competitive grant process played out, Detroit was a real winner in putting together challenges with ways that we can address them in the region using these funds. Next slide. So some of the issues that are being tackled currently, and this grant is a 4-year grant. We are just over halfway through the grant. But some of the challenges we had here in the region were the skill sets of our workers weren't really up to speed with where the future mobility industry was going. Many of our small and medium-sized companies in the mobility supply chain lack the resources to be able to position themselves for better opportunities with future mobility technologies. Our ongoing issue with the startup culture and entrepreneurship, there's a little bit of a risk-averse history here. So really working to really find those homegrown startups and help them flourish. A lack of industrial sites is really a challenge that we'd had. So really attacking what we have available in the real estate sector and making those sites ready for investment. Our proving and testing assets in the region are quite strong. However, they can be very expensive for companies and startups to access. So making those assets better for the startup and entrepreneurship companies, as well as having those sites have all of the technologies needed and improve what they're even offering so that we can test even more in this region. And then also really just connecting this ecosystem. It's a very siloed region in lots of ways. So how can we better connect? And then last, and that's why we're here today, is the lack of data and insights to align the region with a strategy, but also to just educate people on what the opportunities are. So with that, we created 6 different projects. One is based at Techtown Detroit, focused on startups. One is based at our Office of Future Mobility and Electrification at the state of Michigan, that's focused on those testing and proving sites. Supply chain transformation, working with all those small and medium-sized, some family-owned type tier 2, tier 3, tier 4 type companies. University of Michigan is working with to help them to position themselves better for the future mobility economy. Site readiness is being led by the Detroit Regional Partnership here, where we're working with developers and landowners to better ready their sites. Talent transformation is where we are really looking to take the skill sets of our current population and help them to understand the opportunities of the future. And the Michigan Works office through Southeast Michigan Community Alliance is leading that effort. Last, and you can go to the next slide, is the GEM Central program here at the Detroit Regional Partnership, where we're leading in providing research, data, and insights. We're lifting up the region with a lot of storytelling, where we have 3 different social media platforms and newsletters that we're getting out, telling stories that haven't been told. Convening this region in a way that hasn't happened, where we have our regular meetings and regular activities and events with the different organizations that are part of our coalition, and then really focusing on expansion of this industry. This history of light vehicle supply chain, how can we advance that for other mobility sectors? How can we take what we know in light vehicle and apply it to other sectors? So really growing the mobility cluster. So what is the Future Mobility Technology Study and the Road to 2030? We launched this about spring of 2024 with an initial study that S&P Mobility provided for us, where we looked at dozens of future mobility technologies. We came to a small set of them that we felt were best suited for the Detroit region. And we're going to be taking this information with each of these modules and doing a deep dive like we are on hydrogen today. Our website launched last month. The first module that we're doing the deep dive on is the hydrogen module, and we will be releasing another module, propulsion batteries, later this month. And the next slide, you'll see the website, so you can go, and thank you, Bernard, for putting it in the chat. You can go right to the GEM Detroit Region website, and you can find more information on hydrogen as well as the other modules as we release them. And here, just a couple of highlights about what we found from the study and what the promises of the hydrogen fuel cell technology here for the Detroit region. We're looking at great opportunities in light vehicle, medium heavy vehicle, as well as maritime here. You're looking at 31,500 unit growth by 2030. Much of that in the non-light vehicle and light vehicle sector. And then 1,700 new jobs in Michigan. Sometimes people say that doesn't sound like a lot of jobs, but it truly is a great number of jobs when it comes to a new technology really hitting its stride. And most of those jobs you will see are predicted to be in the light vehicle sector. So we're excited about the numbers that we're seeing for this. It is the start of really getting this technology out into the market. And again, I think we have a lot of great information to share with you this morning with Jim and Tarek. Jim?
All right. Thanks, Christine, and good morning, everyone. Again, I'm Jim Saber with Next Energy. I'm going to give a short introduction to Next Energy and some of our mobility work, and then get into what would be kind of a little bit of a hydrogen 101 and what are the uses for hydrogen, some of its advantages and challenges, and then opportunities for Michigan, and then I'll turn it over to Tarek. But as Christine mentioned, Next Energy, we're a nonprofit corporation. Our mission is to accelerate smart, clean, and accessible solutions for communities and cities. We work heavily in the clean energy and clean mobility space. We've been around since 2002, and a few years ago, created affiliation between Next Energy and Michigan Clean Cities to bring a different aspect of our work into Next Energy and to Michigan Clean Cities. And we've really worked to deploy and pilot clean energy mobility technologies in over 30 Michigan communities, primarily through the Michigan Mobility Funding Platform program that we support. We provide access to testing and demonstration platforms across the state, a couple that we manage, the Detroit Smart Parking Lab and the Urban Tech Exchange in Detroit, but then also support the testing improving pillar for GEM with OFME to provide access to other test sites. And we facilitate collaborative research and development programs, some of them involved in hydrogen components, which I'll get into in the next slide or two. In our mobility work, again, we support OFME in the technical program management for the Michigan Mobility Funding Platform. And that's really where over the last 6 or 7 years, we've been able to pilot and test a number of new technologies in Michigan communities and to give companies data, information, and experience with deploying their technologies in real world settings. We're working to support an industry group or coalition made up of Toyota, Hyundai, Shell, Air Liquide, and NEL to develop components that would support 10 kilogram per minute fueling at 700 bar for heavy duty vehicles. I'll get into like the details of 10 kilograms per minute and 700 bar in the next couple of slides, but really think of the business end of hydrogen fueling where the components the user would interface that would be the equivalent of like a DC fast charger. In the Michigan Clean Cities Coalition work, we've done a number of different programs and projects in Michigan around EV car sharing, workplace charging, and technical and outreach programs. We are also supporting the kind of greater Lansing area community with a charging and fueling infrastructure grant that will deploy about 50 chargers in Lansing, East Lansing, and the surrounding communities in the next couple of years. Christine mentioned GEM. We support OFME in the testing and improving pillar to work with test sites in the 11 county area to understand their capabilities, their needs, and make strategic investments in those test sites that create more of a plug and play and ready user access for users. We have supported Electrion in the last few years in the development of the wireless roadway in Corktown. Our role is really to help them with use case and partnership development when we think of static and dynamic wireless charging. And lastly, a new project that we've just launched in the last couple of months is with the Detroit Wayne County Port Authority, where we're creating with them a hydrogen strategy and plan for the ports and the 18 terminals that are affiliated or associated with the ports. And then in a separate effort to strategically invest in a handful of ports with electrified equipment that will accelerate their decarbonization plan. So then go to the next slide. So kind of a hydrogen 101, why hydrogen? The good news about hydrogen is it's one of the most abundant elements on Earth. It's typically found in water and in hydrocarbons. Hydrogen on its own is the lightest element on Earth, and we can also produce hydrogen from multiple methods, whether that's electrolysis, reformation, or even in some cases as the byproduct of other processes. So those are the good things about hydrogen. So the not so good things about hydrogen is it doesn't exist on its own. So you don't you have to separate hydrogen and oxygen and water. You have to extract hydrogen from, fossil fuels, typically natural gas. And so it's not something that we readily find available on its own. It's the lightest element on Earth, which means when we do extract it, it's hard to store and transport. And we also have to store it under considerable pressure to get like a really meaningful amount of energy, in a small volume. So those are some of the challenges that hydrogen has when we think about hydrogen primarily as a transportation fuel. So hydrogen, we use it every day in many different industries. So industrial uses for hydrogen, in steel, hydrogen is a reducing agent for the direct reduction of iron. So it can, replace natural gas or other carbon-based fuels as, for heat as a reducing agent. It's used in cement making to reduce the amount of energy that's required to operate the kilns, food processing, semiconductors, and hydrogen is a key component in the production of what in some cases can be very like clean or renewable based fuels, primarily methanol and ammonia. So there's a number of different ways that hydrogen is used in industry today. Transportation, hydrogen, I guess in full disclosure, and Tarek and I can get into this in a little bit, I'm kind of like a recovering hydrogen fuel cell engineer from about 20 years ago. When we worked on hydrogen fuel cell and internal combustion engine applications with the big three. Things have changed and, there's greater opportunity now, but fuel cells and hydrogen combustion engine applications. Transit buses are a great use case for hydrogen, and we're looking at maritime, aviation, and construction as well. On the power generation side, hydrogen is a great carrier or storer of energy. So as we think about decarbonizing our grid and going to more renewable or intermittent based sources of generation, when you have more generation than load, you can take that electricity, that clean electricity, and create hydrogen and store it for future use. It can be also used in thermal applications, so we can blend hydrogen with natural gas. We can blend hydrogen with renewable natural gas and start to decarbonize how we think about process heat for our homes and workplaces. So, hydrogen density and production. When we think of liquid fuels like gasoline and diesel fuel, we measure them or talk about them in gallons. They're liquids. Hydrogen is a gas. And so we think about hydrogen or gaseous fuels is by weight, or in this case, kilograms. A lot of numbers here, but for practical purposes, when we think about the energy density, a kilogram of hydrogen is for the most part equal to a gallon of gasoline or diesel fuel. So if we think of a truck that might take 60 gallons of diesel fuel, its equivalent might be 60 kilograms of hydrogen stored under pressure. Hydrogen production costs, like currently today, hydrogen from steam reforming of natural gas or fossil fuels, the production cost of hydrogen is somewhere in the $1 to $3 per kilogram range. And if we look at hydrogen from electrolysis, right now that's anywhere from $5 to $12 a kilogram, depending upon what's your source of energy for electricity. So think of the most expensive forms of electricity getting to that $12 range, and the cheaper forms closer to that $5 range. These are production costs. We expect them to come down, but that doesn't take into all of the, I make hydrogen, now I have to store it, transport it, and get it to its end use. So next slide. That on the transportation side, we think a lot of the best uses for hydrogen are really, freight, agriculture, and construction. On the commercial type applications, these vehicles are really big and they're really heavy. If we use battery electric vehicles, the battery never gets smaller, it never gets lighter. And so anytime you're carrying lots of payload, where payload and range are issues, which really for the freight application, that's money, hydrogen can make significant, benefits versus battery electric vehicles or diesel, vehicles. The same thing goes for like agriculture and construction. We're talking about really heavy, large vehicles that to have those to be operated by batteries or powered by batteries, the batteries would be so big that the ability for the vehicle to do useful work would be minimized. In public transit, hydrogen can offer significant benefits versus like battery electric and other fuels, primarily in cold weather. Right? So you have, in the city of Detroit, in the Midwest, and the upper Midwest, we have, 4 seasons. You do have some range penalties when you look at battery electric vehicles in transit applications. Hydrogen also can offer very fast fueling, so minimal downtime of vehicles. So we're really looking with transit agencies to think about how do they get electric buses or electrified buses to last the full day in the full shift with minimal downtime. Hydrogen fuel cells or even hydrogen internal combustion engine buses can be of great value. And then, aviation and maritime, this might not be hydrogen as a gaseous fuel, but like a clean methanol or an ammonia-based fuel or whatever, where, we're thinking of hydrogen as a fuel source for large ships and aviation. So, the activities in Michigan right now, in public transit, Flint MTA has been operating hydrogen fuel cell buses for years. They actually, through renewable energy and electrolysis, they make hydrogen on site at their facilities and fuel, a small fleet of buses today. They've been doing it again for a number of years. The Detroit and Ann Arbor transit agencies are also working in early stages to deploy hydrogen buses. So procuring the buses and installing the fueling infrastructure, we'll see, I think a significant growth in transit applications as we move forward. As I mentioned earlier, the Detroit Wayne County Port Authority is looking to understand how hydrogen can support their decarbonization plans and have used the ports and their terminals as a kind of a launching point for other heavy duty applications. If you think of ports and their terminals, about 55% of the emissions that are generated are actually from the trucks coming in to drop off and deliver and pick up products. And then about 15 to 20% is on-site applications, and the rest is from ships. So if we can decarbonize early on the on-site applications and accelerate the use for hydrogen for trucks coming in and out, we can really make a big difference in our communities and these are also really the hardest hit communities from environmental issues. And then lastly, the Council on Future Mobility and Electrification has a hydrogen working group. And they're, one of the activities that's going on right now in that working group is to look at the state strategy and, making some changes within that strategy to adapt to what's going on in Washington, D.C. at the federal level. So more to come on that. And you'll probably see some things out in the market in, September, October. And then there's been a lot of talk about geologic hydrogen in Michigan and the Midwest, and looking at that and understanding better what's our unique opportunity, given that we could be, living over a large deposit of hydrogen that we could bring into the marketplace. So if we think of like this group here, like what's our opportunity, or when we think of like, GEM, what's our right to win for hydrogen? We have significant, technical expertise within internal combustion engines. They can easily be translated to hydrogen. We've been developing electric drives for EVs, both on the passenger and medium duty and transit applications. If we are thinking of fuel cell vehicles, we already have a head start in a significant portion of that powertrain development. And we don't really talk about it a lot, but every major OEM and every major tier one supplier has had some fuel cell development activity going on for the last 20 years. So technically, we have what we need to move into hydrogen and exploit that within our economy. Our state is also committed to carbon neutrality. A big part of that is, we want to be carbon neutral by 2050. Our utilities are looking to become carbon neutral in the 2040 to 2045 timeframe. That gives us that incentive to continue to purchase and deploy clean energy, renewable energy, which will ultimately lead to a cleaner and lower cost hydrogen over the next 15 to 20 years from electrolysis. And then many of the key industry sectors that we talked about earlier, we already have these in Michigan. So we already have in many cases already user base on the industrial side that could leverage hydrogen as we grow that economy in Michigan.
Okay.
Thanks, Jim. Yep, go ahead, Tarek.
All right. So just really quickly, I'm Tarek Abdul Basit with the Forvia and the Director for Hydrogen Storage Solutions. If Jim mentioned that he is a recovering hydrogen engineer addict, I will admit that I am an active addict to this day. Jim has been my mentor over the last 2 decades to try to help me manage that addiction, and so far working out hopefully okay. So what I'll do today is I'll piggyback off of what Jim has said and zoom in a little bit more on the mobility sector and the different types of hydrogen storage that are available to us, and why we choose kind of one technology over the other. So the next slide here puts kind of a little bit more visual form what Jim has mentioned earlier. And it kind of visually tells you that the larger the application or the longer the range requirement of that application, it begins to favor hydrogen. So for the last, in the beginning, it used to be very much a BEV versus hydrogen type mentality, but we've kind of matured over the last 5 years or so to realize that they're very complementary to each other. If it's a lighter duty type vehicle, passenger type vehicle, chances are it'll go some form of electrification, whether it's a full electric vehicle or some form of hybrid or plug-in hybrid. As that vehicle gets bigger, and the crossover point being kind of that medium duty pickup truck or large commercial van, uh, the packaging, the physics, the economics starts to favor hydrogen more and more. So we see the mobility sector having both technologies existing simultaneously with each other. And the main reason, as you see on the right, why we think hydrogen is better is you get that quicker refueling time as you need to put more energy in. That saves you time compared to a battery. You get, for the same amount of package versus a battery, you'll get longer range. And then typically that package will also be lighter. And for a lot of commercial applications where payload is money, you're paid to carry weight. Having that extra payload directly correlates to a better total cost of ownership. So those are the three main drivers why, as you get bigger, hydrogen will tend to favor, or the mobility sector will favor hydrogen over a BEV. Moving on to the next slide, I'll get a little bit more kind of into the what really drives this. And the best analogy is basically, to keep it really simple, hydrogen is what we call a 3-box solution, and electric vehicles are what we call a 2-box solution. So a battery vehicle is basically the battery and the electric motor to drive it. Hydrogen, on the other hand, needs an extra box. We need the fuel cell engine. We need the hydrogen storage fuel tanks, just kind of like a conventional combustion engine where you have an engine and a fuel tank. And then you add also the electric motor because it's still electricity we're producing. So hydrogen being a 3-box solution on smaller applications generally won't package as well as an electric vehicle can. An electric vehicle and passenger type vehicles will generally give you a smaller package, better range. Being a smaller application, the charge times, etc., the drain on the grid is not as significant. But as the vehicles get bigger, batteries, if you want to double the range, you basically need double the battery. Whereas hydrogen, in a sense, you've already kind of paid up front for that penalty of the engine. And as you add incremental tanks, you're not necessarily doubling the size of the system. You're just adding an incremental 10, 20% or more. So as the energy requirements increase, as the vehicle gets bigger and needs more range, the package overall gets better looking than a BEV. And that's why we see that kind of crossover point that you see in the middle of the page, where kind of that commercial van, heavy duty pickup truck is about that point where hydrogen starts to package better. Ironically enough, we see a lot of the same kind of metrics and physics happen on the infrastructure side as well. The electric grid, it can handle very much a lot of the lighter duty vehicles, but as we get into very high power, seasonal, what we call kind of difficult to decarbonize industries like steel, like ammonia, like heavy duty trucks filling up, the same reasons why hydrogen kind of makes sense and the crossover point on the vehicle become also apparent on the energy grid side of it as well. A Class 8 truck, for example, needs 10 times, as they fill up, need 10 times more fuel than a passenger vehicle does. And they fill up more often because those trucks are running much longer. They're running much longer shifts than an average passenger vehicle is. So the demands at a fueling station for a Class 8 truck are much, much, much higher than you have at a typical passenger fueling station. Demands for heating in the winter, huge amount of energy required in one season in a few months. Today, that's why we heat our homes mostly with natural gas and not with an electron in a grid. So we see hydrogen very much kind of playing the same role as we do today. There's a place for a molecule and there's a place for an electron. Okay, moving on. So in terms of the different kinds of hydrogen storage systems that are available to us, there's quite a few different ways to do it. And you'll see in a lot of press releases, some, magic new molecule that has the promise to quadruple our range, or be a magic new storage solution. So I'll break them down really, really quickly in terms of the different types and options that are available to us. And the first main kind of bifurcation is what we call physical-based systems, where we literally just take the hydrogen molecule and compress it or liquefy it, kind of in the way that Jim mentioned earlier. And that's just the physical storage of the system. And those are kind of the more common systems you'll see and the ones that I'll focus on the next slide. But there's a whole other world in what we call material-based storage systems, in where hydrogen is stored kind of in a chemical reaction to another a molecule or another element. It could be kind of stored as a chemical bond, and then we have to release it, or it could be stored kind of like a magnet where it sticks, like a Brita filter, for example. It'll stick to a molecule, loosely stick to a molecule. And each one of these, there's literally hundreds of different molecules that the community we've been investigating over the last 2 decades. A lot of them promise to have better capacity in terms of being able to store more hydrogen in a smaller package than some of these physical-based systems we're talking about. But all of them at the moment, have some major kind of drawback that by the time you build that mini chemical plant around that molecule and getting the hydrogen kind of to the point where you need to be able to use it in an engine, you end up probably no better or sometimes slightly worse off than just strictly compressing it or liquefying it. And Jim and I, we both have firsthand experience on working on these materials in a previous lifetime a few decades back. So we're both kind of keenly aware of some of these potential drawbacks, but we still remain very optimistic that we haven't fully explored all these options, and that there is out there, we believe, potential solutions that could one day significantly beat the incumbents of compressed gas and liquid hydrogen. So the community continues to look at these. It just, today, there isn't one that kind of ticks all the boxes that we need to put in a vehicle. Okay, next slide. So of the options that are more commonly available today and we're looking at putting into the vehicles, three of them in the mechanical, what we call them the physical storage. So compressed gas, probably the most common one today, liquid hydrogen, and then kind of a combination of the two that's always investigated as cryocompressed. So starting with the compressed gas version, as Jim mentioned, we have to compress this gas into very high pressures to get it to a point where there's enough useful density in a small package that we can get reasonable ranges out of a vehicle. So the two incumbent technologies today, are pressures that the industry uses, are 350 and 700 bar, which translates to 5,000 or 10,000 psi. So very, very high pressure systems. compared to kind of other propane and natural gas that are much lower pressures when you see those in a pressure vessel. One of the advantages in most of the vehicles that you're going to see go to market in the next decade will be one of these 350 bar or 700 bar. Most buses will probably go 350 bar, but most long haul trucking Class 8 type vehicles will probably go 700 bar. So some of the advantages is it's a fairly well-known technology. It's a fairly simple technology to the other two and even the chemical-based ones. It's a well-known, we've done it in natural gas, we've done it in propane. We know how to do compressed systems. It fills quickly. The tanks are incredibly durable and safe. We know how to do this industry. Now, the drawback though, is because of those high pressures, we need to use a lot of, exotic carbon fiber to make those tanks, and they're currently quite expensive. So we're still an order of magnitude higher in cost than where we would be with just a traditional blow molded diesel tank that would go into a truck today. The other little bit drawback is that in compressing to those very high pressures, we have to use some of the available energy of the fuel, and we use today 10 to 20% of that energy just to compress it and get it in the form that we need. So moving on to liquid. Liquid hydrogen main advantage, again, a fairly mature technology. We've been doing liquid hydrogen and liquefied cryogenic gases and fuels for a long time. One of the big advantages is in the same amount of volume, I can double or triple the amount of energy I have in that space. So that, directly correlates to, double or triple the range in a vehicle. But it's very, very cold. So we're replacing high pressure carbon fiber with exotic insulation and vacuum layers. So the major drawback though with liquid hydrogen is it's a very much a use it or lose it proposition. If you don't use it, you can begin to lose 1 to 2% of it per day. So in applications like long haul, it's going to work well. But if it's in say like a bus application or a truck that parks for several days to weeks at a time, you might come home to an empty tank. And its other major drawback is that to liquefy, we need even more of its inherent energy to get it to that liquefied state, a very, very cold temperature. So that again eats up some of the available energy and kind of the well-to-wheel kind of benefit of the fuel. Moving on next to cryocompressed. I won't spend too much time because there's not really any systems that we're going to see on the market in the near term in cryocompressed, but this is a combination of the two. You take some amount of pressure and some amount of cryo or cold temperature, and you increase yet the storage density more of the fuel. That's the attraction of it. But as you can imagine, doing cold and high pressure becomes an incredibly complicated system, very difficult to manage. You still at some point have some of that boil off issue that we talked about with liquid. So it's a very complex system. There will be some applications for it, but in kind of a day-to-day customer retail environment, probably not going to be our best solution. Okay.
All right, thank
Yeah.
you. Wow, that was a lot to take in.
Yeah.
You are both really excellent resources for us related to this technology. We did have a few questions come in, so I want to get to those, and then any other discussion points that you want to add if you had any other thoughts that came up while each of you were speaking. The first one I want to ask is there any collaboration with the Michigan Hydrogen Initiative at the University of Michigan? Jim, I don't know if that's something you're familiar with at U of M.
Yeah,
Okay.
and so U of M, they've been heavily involved in a lot of the activity planning and strategy for the state. One of our most recent kind of working group meetings was kind of a larger meeting at the University of Michigan with their team talking about opportunities for and timelines for clean hydrogen or green hydrogen as we move forward. So there's a lot of collaboration, and they're heavily involved in the planning and strategy.
Okay, excellent. I know that's so with so many initiatives, just making sure that things are connected as best as possible. So I appreciate that question. Another question coming in is related to the state of Michigan budget. And apparently this participant in the webinar said that there is money in the budget in 2025 for clean fuel and charging infrastructure, and the amounts of 30 million and 22.3 million for the support of construction of hydrogen fueling stations for heavy duty vehicles. Basically, they're saying that the state is the state committed to deploying these funds? I'm not sure if any of us can answer that, but they said funding seems to be focused on electric vehicle and EV station and infrastructure deployment, not the heavy duty vehicle hydrogen fueling station infrastructure deployment. And I'm not sure if we're in a position to answer what the state is looking to do with those funds, but maybe you have some insights.
Yeah, I mean, I really can't speak for the legislature or
Right.
others in that aspect, but I do know that in the work that Next Energy's taken on with the ports and some of the discussions we've had with OFME and MDOT, I think there's considerable interest in hydrogen for heavy duty in transit applications. And partially because like we kind of think of it, and if I really want to make it really simple, in going back to some of Tarek's slides, typically thinking if it runs off gasoline today, it most likely will run off a battery in the future as we go to clean technologies. If it runs off diesel fuel, those are the bigger, heavier vehicles that would most likely, move to hydrogen. And so that gets us into, public transit. It gets into, local fleets and other applications. And that's also where we're going to see like a significant benefit as we start to decarbonize and what that means for our local communities. So when we think about, our, kind of carbon neutrality and our pathway, to that, hydrogen will play a big role in that. And, most of the departments, I don't know of any department in the state government that's not interested in it, but, whether it's OFME, MDOT, Eagle, lots of organizations will play a role in moving that forward.
Mm-hmm.
And in like the carbon and in the charging and fueling infrastructure programs that are ongoing right now, hydrogen is is one of the technologies and systems that can be looked at through the CFI programs.
So it's definitely on the radar, hoping for some deployment. Another question that's come in, would hydrogen be suitable for the Detroit Q line, which is the transit train that goes up and down Woodward Avenue, since it runs all day? Would that be a suitable fuel?
Tarek, you wanna?
Yeah.
Yeah.
So potentially. So we see a lot of train applications. Most of the train applications we see are usually kind of in the yard, kind of the trains that do all the moving around, not necessarily the long haul type trains. So these kind of public transit type trains are kind of very much an in between, right? They can put on a fair amount of distance. So there is an application for them. But a lot of times, if you already have a really good electric infrastructure set up, it might be kind of a difficult one to displace. But train is an application that has a lot of active work in hydrogen. Usually what we're looking at is the yard haul type applications, though.
A lot of what we're doing here at GEM is working with the supply chain and helping the supply chain, as I said earlier, to be better prepared for future technologies. I'm going to ask Tarek this one. Where do you think the opportunities are for Michigan suppliers, i.e. like those that are involved in insulation, material-based storage systems, or other layers? What do you think the opportunities are for them with hydrogen?
So I think Jim touched a little bit on it in the beginning, but for sure, in terms of a fuel cell vehicle or a hydrogen vehicle, in many cases is an electrified vehicle. So on one end, where we've made gains in terms of electric motors, everything that we do in a powertrain today that we worked on, that carries over into hydrogen. On the other hand, and one of the beauties of hydrogen is because there's so many different ways to make it, ship it, and use it. H2 ice is another example that's gaining ground. It's gaining ground in Europe already, where it's been accepted as a zero emission technology, and we're advocating for it here, also in the U.S. Of course, when it comes to combustion engines, who better than Motor City? This is kind of our strength. So 98% of that know-how carries over in making a diesel engine into building a hydrogen engine. So that entire supply base, the know-how, all of that carries over quite nicely to hydrogen. So whether we burn it in an internal combustion engine or we use it as an electric type vehicle, I think we're well suited to handle either way that it goes. And again, I'd say the two are complementary, so we're well positioned for whichever way this goes.
And I would say keeping our supply chain
Yeah.
in tune with what the changes are that are happening here and the opportunities that can come with this transition. So really making sure that these companies are aware of it as well. I think there's less understanding of some of these opportunities. So the more we can talk about it and get it out, the better. If you had to pick one, what is the biggest hurdle for adopting hydrogen as a fuel source over the next 5 years or 10 years? Is it cost, availability of vehicles, fueling stations, policy? Like, what do you think would you say in your positions, would be the biggest hurdle for this technology really gaining its stride?
So maybe I'll start. For me, it's the fueling infrastructure is number one. Kind of build it and they will come. And I think maybe one of the things that we've maybe approached probably incorrectly as an industry in the past, a couple of different things that were done was we tried to replace one for one fueling stations with a gasoline station today. And I think there's a way to do it, and we believe there's a way to do it more incrementally, to do it with smaller, kind of more modular stations, particularly what we call a captive fleet model, where you have vehicles and fleets that come back to base, so you can serve more vehicles with less of a station. I think we have to pursue that route in terms of building out the infrastructure. And we do see momentum happening that way. We see in the last 5 years a lot more effort, a lot more companies, a lot more startups in that kind of mobile modular refueler space coming. So I'm encouraged to see that that chicken and egg situation we've been talking about for a long time with hydrogen seems to be finally getting resolved. But I think we need to move incrementally and start getting stations, and we have to do it in a synchronized way where the vehicles show up with the stations. Otherwise, each side will be kind of pointing, well, I'm not going to build a vehicle until a station's there, and vice versa. So it has to be well coordinated, incremental, and kind of grow it organically.
Yeah, I mean, I would just add, my thoughts on this is it's the fueling infrastructure. And, if we think of but in fleet applications, like where Tarek talked about, where, the group of vehicles come back to a central point every day. We already have a lot of experience with fleets operating off of natural gas, where they have their own fueling infrastructure, fleets operating off of propane, where they have their own fueling infrastructure. And I mentioned earlier, like Flynn MTA has its own fueling infrastructure for hydrogen. So if I think of commercial fleets, where you're operating in the same metropolitan area all day and you're coming back to a central point, public fleets, whether it's transit buses or larger vehicles, where you can, build your own or operate your own infrastructure on site, like you would for a natural gas fleet or something like that. That's where I think the applications will come first, and then we will, then we can synchronize and do all the other things to, what happens with other vehicles that have to come in and out or service those sites. So I think fleet applications will be big as we move forward, and thinking about the fueling for those on an on-site basis.
Helpful. Do you think that we're on the cusp of any incremental technology breakthroughs that could decrease the cost of hydrogen in the heavy truck use case? Is there anything on the
It,
horizon that you're seeing that could help lower those costs? Make it
so
happen?
for me, I wouldn't say there's a breakthrough on the horizon, or nor that it's actually even really needed. What we've seen over the last 10 years is very steady incremental march towards the targets. It's been pretty linear in terms of the improvement. The technology, I'd say today, is at a point where when it scales, there's quite a few business cases that will make sense. I don't think we're either in the fuel cell or the storage system 100% there to be a complete replacement for every application where diesel or gas is used today. But there's a steady march, and we're starting to transition towards building kind of higher volume plants, higher volume manufacturing facilities, um, where we can make a significant penetration. But in terms of breakthroughs, not immediately on the horizon. Um, we probably still need one or two big breakthroughs to be able to 100% replace the current infrastructure. But with what we have today, we can still make significant penetration, I think.
Anything to add, Jim?
Well, this might be a little controversial or whatever, but so like Tarek, we've been going on this steady path of, 15, 20 years ago when we were thinking about fuel cell efficiencies, we were like, gosh, we can get to 50%. That's great. Well, now we're like at 60. And so that's a huge, improvement. And we've made improvements in electric drives, and we've done a lot of different things. And we have more clean energy available to us today. That's another big and continuing to have more clean energy available that will produce a cleaner fuel. I think one of the things that we don't always think about is like we've been at internal combustion engine technology for over 100 years. So what's the breakthrough that's going to happen in internal combustion engine technology that's going to dramatically increase its efficiency? And how likely is industry going to invest in, how much will they invest for a 1% improvement or a 2% improvement in, combustion efficiency? And so I think there's just more opportunity for bigger gains when we start thinking of electrification and hydrogen that will really, drive the application. We have much more room to grow.
Excellent. Are you aware of any studies that, and this is interesting, looking to retrofit diesel engine systems with hydrogen fuel kits to transition that current equipment versus investing in completely new systems? Is there any retrofitting opportunities?
Yeah,
Tark?
so I can take that. So first of all, they're all the major diesel manufacturers today. You look at, say, Detroit Diesel, you look at, Daimler, Cummins, Toyota. They all have active programs today where they're working on next gen engines where it's advanced diesel, CNG, and hydrogen, all built off essentially one platform. So I'd say, with the major OEMs, there's already activity where they're kind of commonizing a lot of those components. There are some really interesting other technologies that are out there today. There's a company that I'll point to in Edmonton in Canada called DTI, where they do a blended fuel approach where they blend hydrogen directly into a diesel engine, and they do a retrofit kit for that. And they can get anywhere from 10 to 60% reduction in emissions and NOx with those kits. So that's a company, and there's multiple others out there like them, but that's one that comes kind of top of mind. That's a product that's available today as a retrofit kit that they offer to fleet customers today that are using the traditional Class 8 vehicles, buses, for example, some of those bigger diesel engines. There are multiple kind of examples like that are out there today.
We have just a few minutes and a lot of questions still, so I'm excited about the interest in all this. One is for aerospace applications, think eVTOLs. Would there be any additional challenges or benefits compared to terrestrial applications? So Tarek, I remember hearing you speak a few months ago at the auto show, and you were talking about, just some of the opportunities in aerospace and in, you know, refueling and airplanes and
Yeah.
that type of thing versus light vehicle. So do you see any other challenges or benefits to really looking at that as an area of great interest?
Yeah, so it is definitely something gaining in interest. We get a lot more queries, more and more every day on particularly on drones and eVTOLs. I think as these applications get bigger, switching over from battery to a hydrogen source, kind of the same reason, right? This thing gets bigger, you want longer range. The exact same kind of metrics apply. And it's still obviously it's very much a Wild West kind of space right now. The drone space is growing quickly. Still a lot of unrealized applications, and we're finding new applications every day. But as we're looking for more and more delivery, for example, with drones, these things get bigger. They need higher payload, so the same metrics apply. So we're talking to a lot of companies in this space, but it's still a very much an unregulated space in terms of the regulations for the tanks itself. And there's a mishmash of different regulatory bodies out there, and they're not necessarily all quite aligned yet. So still very much Wild West, but growing quickly in terms of interest and potential applications.
And yeah, so
Yeah.
many opportunities, I think, with
Yeah.
that whole area. So another area of our GEM focus here in the region is the jobs that will be created by these technologies. What kind, if you have any idea, but any ideas on what kind of jobs do you think out there are going to be needed to support the adoption of hydrogen? So obviously there's the engineering and all that. Are there other types of skill sets and jobs that you think are going to be critical for us to be able to maintain this type of energy source here in the Detroit region?
Go ahead, Jim.
I'll go
Yeah.
first, I guess, in this. I mean, I think it also depends on the pathway that we, go down from like where we are today to the future. If we think of, the hydrogen internal combustion engine, it's, as Tarek mentioned, it's like 98% the same. So we think of the engineering, the manufacturing, the servicing. I mean, a big thing about when we look at new technology is how do you fix it in the field? If we, are able to move forward with and start to move forward with internal combustion engine technology, we keep a lot of that same workforce in play, in that expertise in play. As you go towards, the fuel cell type thing, it's an electric vehicle, so there's still a battery, there's an electric drive, but that fuel cell with hydrogen, you still have a lot of mechanical components. And so I think, it's I think of the jobs and all that, a lot of like who's going to build them and who's going to maintain them. And are there new skills required for servicing and maintaining them? And, the answer is yes, a little bit, but a lot of it is, um, if you know how to work on a valve for an internal combustion engine, you can work on a valve for a fuel cell or, a solenoid or any of these other pressure systems. So I think in the transportation side of it, it's a nice transition because we can, keep the workforce that we have today employed and in place and, build some of the skills that we may need in the future when everything's electrified.
Mhm,
And
mhm.
maybe what I'll add to that is our own kind of internal experience just hiring within our own company. And I forgot to mention earlier that, we're a large tier one supplier. We're kind of a top 10, we have hundreds of thousands of employees. We, one and two vehicles today has a part from us from one of our divisions. So we have skill sets all over the place in the mobility space. And one of the things that I think is nice to highlight is because this is a clean tech, it's really easy for us to pull from within our own ranks and our own from our other divisions. Exhaust systems is one of our big divisions, and a lot of that skill set from exhaust systems, a traditional exhaust system, transfers well to hydrogen. A good engineer is a good engineer, and a good manufacturing engineer or technician is the same. You have a small learning curve and you transfer. But what's been nice is really easy to pull either from internally or externally because of the clean tech aspect of it. So it's able to attract young talent, existing talent, and it's made it easier to pull. I mean, one of the things we talk about is how do we bring talent back to Michigan, for example, and pull it away from, you know, the coasts. With hydrogen, it's been pretty easy to pull that talent where it may not be with some of the traditional divisions that we have.
Mhm, mhm. I am really excited to have learned so much in the last hour with you two. Thank you for the participants and all the questions. I am really looking forward to seeing hydrogen finally make its move. I think it's a technology that's been right around the corner for a long time, and hoping that we'll finally be seeing it come into its own in the near future. So, Tarek and Jim, thank you so much for taking time with us this morning. I want to make sure that everyone takes advantage of these opportunities. Our next one will be on battery propulsion, and we'll get that announcement out shortly. In the meantime, enjoy the rest of your summer day, and appreciate again all the interest in hydrogen and what we're doing here at GEM. Thank you.
Thank you.